So hello everyone. So we have Josh Long from Spring, and today he is going to talk about the reactive Spring part, which is very interesting, especially to me also. And Josh is a Spring developer advocate at VMware Tanzu, and although he no longer needs any introduction, but I am honored to introduce him. So thank you so much, Josh, again for presenting and teaching us these goodies and things like that. So over to you. You can start now.
Well, thank you so very much. I appreciate that's very kind introduction. Let me share my screen. Is that okay? Can I stop your screen?
No, you can share your screen. No worries.
Okay. Don't want to step on anybody's toes there. All right. Thank you so much, everybody. I appreciate that. I know that it's Saturday in California, where I am right now. And I know that there's a lot of places that you could be, but you have chosen to instead be here with us, and that's wonderful. So I don't want to waste your time. This is why every single one of my presentations starts off with, first and foremost, this slide where you can find my information. So if you have questions, comments, feedback, whatever, don't hesitate to reach out to me. I'm a Spring developer advocate. I'm a Kotlin Google developer expert, a Java champion, and of course, I am at your service. So if you have questions or comments or feedback or whatever, you can find me on Twitter. I am at StarbucksMan on Twitter, or you can find me via email, josh@joshlong.com. Either way, very happy to engage, very happy to connect. And of course, when you have questions, when ineluctably you have questions about what we've just talked about, do not hesitate to reach out to me. Obviously, the code is there at the bottom, but I'm not, I hope you look at the code. I hope you get something out of it. But if you have questions, comments, feedback, whatever, you can find me on the internet there. Okay. As part of what I do, I used to travel and I got to go visit places, and it's 2020, so it's a little different. But nonetheless, it's really nice to be able to talk to people all around the world. I have done some training videos. These are on Safari, on live lessons. I wrote a book called Cloud Native Java, which is available in a number of different languages. I have a podcast every Friday where I talk to amazing people. And this week I had an interview with the one, the only, the legendary, the inimitable, the amazing Dr. Heinz Kabutz, who's, if you've used Java for more than a minute, you know Dr. Kabutz. He's an institution, a legend in his own right. And of course, I have a blog I do every Tuesday called This Week in Spring, where I just round up all the news that's fit to reprint in the Spring ecosystem. And of course, I have a screencast series that I do every Wednesday called Spring Tips, where I look at different parts of the Spring ecosystem in depth in my 25 to 45 minute long videos. Sometimes they're a little longer, sometimes a little shorter, but either way, they're quick, right? And I have a book I just wrote called Reactive Spring, and that's what we're going to talk about today is reactive programming. Now, you can see we're on this slide. It's not going to change for a minute. I'm just going to talk to you for just a few minutes, okay? Let's consider why we care about reactive programming and what it gives us. What we care about when we build reactive applications is that we have the ability to build software that is more resilient, more uniform, and more scalable. Okay, these are the three things that we want from reactive programming. Now, of course, let's just take a brief digression, ever so briefly, to consider why we care about these three things, right? It's always important to tie what we do here in the technology spectrum, in the theater of technology, to the real world, right? Because nothing that we do here makes any difference unless it connects to the real world. So why do I care about reactive programming? Why do I care about uniformity? Why do I care about more scalability? And why do I care about more resilience or more robustness? It's because hopefully, my organization is in a situation where I'm doing a lot more services. I'm building more APIs. I'm building more services and systems that talk to each other. And that implies network communication or input and output. And that's where we have a problem. And the reason that people care about more services, of course, is because there's this move towards things like microservices, this move towards things like APIs and so on. And we see that proliferation of client-server sort of style architectures or microservices. And obviously, I've done whole other talks about that particular move, the sort of motivations for it. But suffice it to say, a lot of people are moving to smaller, singly focused, independently deployable, reusable, bounded contexts or microservices. And the reason that we do this is because smaller code bases require less coordination in the team. They make it easier for teams to coordinate. They make it so that we can deploy software into production faster. And going faster gives us a competitive edge, right? The ability to make a change, see the change deployed, get the feedback, and then iterate based on that feedback is powerful, super, super valuable as well. So going faster is good. We get there with smaller code bases. Those code bases are doing less things. It's not like the scope of our business logic has dwindled or diminished. It's just that we've got smaller, discrete code bases that that serve to build or implement all that business logic. And these things now need to talk to each other since they're no longer bundled in the same mega.ear archive or something like that. These things are now separated over the network. They still need to talk to each other. And that means we introduce the complexity of building distributed systems. So when we do that, we hit a few bottlenecks that we may not have appreciated were possible before. One of which is our ability to scale, right? And there's two points there where you might have trouble scaling. Most people see it in terms of the ability to do input and output based on the number of threads. So if you use traditional input and output in Java.io, java.io.asterisk, you'll find the input stream and output stream classes. Imagine you're using an input stream to read data from a socket or from a file or something like that. You're just doing you've done this code a million times, right? While read line does not equal -1, then you scoop up the data and put it in a byte buffer and you accumulate it or do something with it or whatever, right? And then you keep doing that until you have all the data. But as you say, input stream.read, what's happening to the thread, probably main or some other thread, right? What's happening to that thread when you're doing the input and output? It's blocked, it's stuck. It's unable to do anything, right? And that's because input stream.read is what we call a blocking call. And so as a result, when you ask for more data, you can do nothing with that thread. And that would not be such a big deal if threads were infinite and cheap, and if input streams and output streams were infinite and cheap. Unfortunately, they're not, right? A thread is expensive today, right? And before Project Loom comes in hopefully in a year or so, maybe a little bit less, before that comes, threads right now are very expensive. It's not easy to create infinite numbers of threads, right? And even when Project Loom comes, creating threads is going to be much cheaper. We'll be able to create many more of them. The problem will be that input streams themselves are not cheap, right? They actually take up RAM in memory. And so, kilobytes of space per input stream. So even if we can create millions of threads, which is what we hope, right? Even if we can do that, we won't be able to create millions of file descriptors or input streams because that'll, will bankrupt our RAM budget. So this is where it's very important to be more resource efficient, okay? That's the first thing we care about. Now, once I've got this ability to be more resource efficient, and I get that through reactive programming because I am given a programming model that allows me to say, hey, runtime, I am doing something that doesn't require a thread. I can just wait for it asynchronously. I can have it call me back, and when it's available, then I'll need some time on the scheduler, on the thread to do some work. But since that hasn't happened yet, here's the thread. You can have it back. Thank you so much. That's what reactive programming gives me, is it gives me a paradigm in which I can tell the scheduler, tell the runtime when I'm not using a thread, okay? So that gives me more resource efficiency because now I can reuse, I can share the same finite number of threads more efficiently. And in order to do that, I need to take advantage of asynchronous I/O, which is not Java I/O input stream and output stream, okay? First thing. Once I've done that, now I've got communication over the network, right? Now I've got one service going faster or slower than the other one. I've got possible network outages and volatility and topology changes and so on. This means I need to care more about the volatility, the implied volatility of building distributed systems. We now run the risk of running afoul of the fallacies of distribution, right, of distributed computing. And so we need to care about those things. And we want our programming model to give us a way to, first of all, when there's too much data, to push back. That's called back pressure in the reactive world. And we're going to see that manifest in the APIs in just a moment here. I also want some way to say if something goes wrong, for example, I want to retry, or if something fails, I want to be able to time out or whatever. Or, I want to have error handling and so on. So I need a uniform way to deal with the reality, which is that the world is wide and open and there's lots of different sources and sinks for data, but I want a consistent toolbox to use to be able to address and handle failures in all those different sources and sinks. Reactive programming gives me that. Finally, we've got resource efficiency, we've got robustness, and I want a uniform API, right? Like I said, I've got all these different sources and sinks, I want them all to be the same kind of thing, rather than having different APIs to describe what is essentially the same thing, right? Think about it, right? If I ask for if I make a network call, an HTTP request to an HTTP server using Apache HTTP client or the Spring REST template or something like that, I have one API to ask for data. What am I given back? Well, I might be given an array, might be given a collection. But what if that data that I'm looking for is long-lived? It's a long-lived socket, and it's going to give me data over an hour. Well, maybe HTTP isn't the best fit for that, right? You could probably use servers and events, but even there, the API and the client's going to be very clumsy. Maybe I could use WebSockets. Okay, that's a different API. What if I'm talking to a Kafka broker and I want messages that arrive asynchronously in potentially large numbers, right? It might be one message, it might be a billion record messages, it might be a trillion, or it might be unlimited messages. So I can't really say, select all from Kafka or something like that. That doesn't work. I can't scoop all that data into one buffer. You have to say, I want to be notified asynchronously as each message arrives. So we now have a different API. Same thing for route and queue. Same thing for server-side events. Same thing for JMS. Same thing for all these different things, right? So we have different ways of describing, hey, here's the thing. It produces data. I want a reference to it. And as each record becomes available, whether it's all available right now or each record becomes available one after another over many, many hours or days or weeks or whatever, I want a uniform abstraction. Reactive programming gives me that. So resource efficiency, consistency or uniformity of interface, and robustness. That is to say, primitives I can use to address the limitations of building distributed systems, to introduce fault tolerance into my services. So I want all of that in my code, and I want to do so in a way that's consistent and familiar for somebody who's ever built a server-side JVM-based application. And here's where Spring can really help, right? Spring introduced a brand new reactive web runtime in Spring Framework back in 2017. And since then, the entire ecosystem of Spring projects now support, wherever possible, reactive programming. And that's the journey that we're going to see today, my friends. We're going to look at all these different components and see how they fit together by going to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. So what I'm going to do is I'm going to build a new service called Customers. And I'm going to build an application using Spring Boot 2.40. The Maven support, fine. I want Java support, great. I'm going to use the 2.40, and there's a lot of great features here, friends. A lot of great features in Spring Boot 2.4 that you should care about. One of my favorite features, one of my all-time favorite features, is that it now works really well with the Spring GraalVM native image project. Now, I don't have time to show all of that. That's a whole other talk. But the result is that you can take your Spring Boot applications, and for huge categories of applications, huge swaths of applications, not everything in Spring, right, is ready, but lots of stuff are, including the stuff I'm going to show you today. So I can take all of that and I can make it work in a native image application context. And the way that works is I take my code and I compile it to a native binary, machine-specific binary, right? So the time it takes to do that is actually fairly substantial. The code that you have to do is just a minute or less, right? It's nothing. And it's just configuration to your build, basically. But the time it takes to compile is substantial, right? So I have a application code base here, and it's pretty trivial, friend. It doesn't do, let's see, it's pretty trivial. It doesn't do a whole bunch of stuff. It's a reactive application that talks to a database. So source main Java, whatever, WAG application, and reactive starts up, creates a table, writes data to the database, finds all the records, prints it out, creates a Spring data repository with an entity. There's an HTTP controller, that kind of stuff, right? And it's using 2.40, and Java 8 or 11 works just fine. The only thing that's interesting is this, and this. This is the build support in Spring Boot 2.4 for building Docker images. You know that Spring Boot 2.3 and 2.4 have a whole bunch of features targeted specifically at container-centric platforms like Kubernetes, including native graceful shutdown, including native support for readiness and liveness probes, and easy push-button simple Docker image creation. In fact, you don't have to do this if you want just a regular Java JVM application inside of a container. But if you want a native image inside of a container, then you have to do all of that. Look at that, those 3 lines, that's terrible. So as a result, I have now this application. I can say Docker, Docker images, And I have an application. I think it's, what did I call this? What did I call this, friends? I called this WAG. Okay, so grep WAG. I could have done AQI there. Okay, so run this one. Docker run. There you go. There's my native application inside of a container, right? So I'm doing a Docker image, and then I'm starting the application up, and it starts up in about 0.176 seconds, right? So a tenth of a second. And actually, it's faster than that if you run it on your local machine, but because there's Docker there, it takes a little bit longer. It takes an extra second almost to start this application up. So this application also uses H2, which is an in-memory embedded SQL database. And so because it's using H2, it's got an embedded SQL database in the JVM process or in the native image process. So I'm actually starting up my server, my application, right? My HTTP API, and my data access client, and also a database, and it still takes about a tenth of a second. Pretty great, right? So that's a cool feature. I encourage you to check it out, but that's not what we're here, friends. I just wanted you to know about that. It's not yet GA. That's why we're not going to spend too much on that right now either. So we have this. We have also the choice of version of Spring that we want to use, or version of Java. I always use the latest and greatest whenever possible. Obviously, I'm a big fan, so I'm going to do that. These are choices that you could make, friends, things that you should choose or could choose, but I encourage you, as always, to choose the latest and greatest one. Java 15 is the current it's the current supported version. Java 11 is the current long-term supported version, and Java 8 is a non-choice. It's a choice that you could make, but again, that you should not just because it's technically inferior, but because it's morally inferior. You will not appreciate, you will not love the look of despair and frustration and sadness and shame on your children's faces when they find out you're using Java 8 in production. Don't do it. Do the right thing. Be the change you want to see. Use Java 11 or 15 or later. Now, I'm going to bring in Lombok. I'm going to bring in the reactive web support. I'm going to bring in the R2DBC support. I'm going to bring in, what else do I need? I guess I need that. I want the... don't want anything else. I think that's it, actually. That's enough. Oh, I want a Postgres database. I'm going to talk to a SQL data store. So, you know what? Better yet, I won't use Postgres. I'll use H2, just like last time. So there you go. Lombok, Reactive Web, R2DBC, H2. And I think that'll do. That'll give us an application that has everything we need to talk to a database and to create a little API, right? So let's go ahead and hit generate and open this up in the IDE. And again, it doesn't really matter what IDE you use, so long as you use something that you're comfortable with. So Visual Studio Code, NetBeans, Eclipse, IntelliJ, all of these are just fine, and Spring Boot works just fine with all of them, right? And it has for a long time. You don't even need to buy the professional, expensive version of IntelliJ if you don't want to, because it's just public static void main. There's nothing special to it, right? So here's our customer support. Okay. And we're going to point it to the right JDK. Thank you. Okay, so now what we want to do is we want to build an application that talks to a database. And so that database, we don't need to configure because we've got H2 running in the background. But I'm going to describe an entity of type customer that's going to have a field of type ID, which is going to be a primary key. And I'll signal it that it is by using this annotation there. I'll have another field here called name and another few records called no args, all args, and data. Okay, so these are my basic annotations to create getters, setters, toString, equals, hash code, etc. Java 14 and later have a preview feature called records. Kotlin and Scala and every other language ever has equivalent feature, case classes, data classes, etc. But either way, this is what we get in Java for now, since I'm not using preview features. And what I want to do is I want to write data to the database using this repository. So I'll create a reactive CRUD repository of type customer, whose primary key is of type integer. And this repository has methods like find, save, delete, count, etc. All of that's pretty normal. But what you may not have seen before are these parameter types. The first of which is a publisher. A publisher publishes data asynchronously to a subscriber. When the subscriber first subscribes to the publisher, it is given a subscription. We'll come back to that in a second, okay? We'll talk about that in a second. When each new record arrives from the publisher asynchronously in the future, right, in a nanosecond or a millisecond or an hour or a week, then we call on next. When there's an error in the processing pipeline, the on-error method gets called. And when we're done processing the data, the on-complete method gets called. So we have a very simple life cycle there. And it all starts with, as I said, the subscription. And the subscription is what the subscriber uses to ask for more data from the publisher. So the consumer, the thing that's processing the data, is in charge of the speed at which it consumes that data, right? Super important. And I don't think that's controversial, right? I don't think you need to be convinced of the benefit or the implied benefits of that arrangement. We do this all the time in other circumstances, right? In other contexts. When, for example, we use TCP and UDP and we create network services, we think about message framing and overflow. What happens if one one socket produces more data than the other one can handle, right? So we talk about flow control there, very, very important. What about in a distributed system? We have a service or a cluster of services over here, and we have another service over here, and we want to make sure that one cannot overwhelm the other. Well, in this case, you use a message queue, right? You have a buffer so that you can serialize all the requests and then easily drain them by having aggressive consumers on the other side to drain that data. Again, very, very natural thing to do, super natural. So we have understood at the systems scale how important it is to have the consumer be in control of the consumption of data. We understand at the very tiny level of input and output of protocols and so on, how important it is for that to happen. All we're doing here is just formalizing that at the API level. Now you have primitives in the Java code that you can use to control that if you want to. This is also sometimes called back pressure, and I talked about it earlier. Okay, so publisher, subscriber, subscription. The fourth type, by the way, that you don't see reflected in this list is processor. Not that one, processor. A processor is a bridge. It's a source and a sink. It's a producer and a consumer, a publisher and a subscriber. It's a thing that pushes data and it consumes data, okay? So now we have our reactive streams types. Those come from org.reactivestreams. That's actually the result of a collaboration, by the way, from the Spring team with Netflix, Lightbin, the Eclipse Foundation, etc. So it's a sort of de facto standard. And then we have the specialized types from Project Reactor, which is from the Spring team. And it complements, or you can liken it to RxJava or to Akka streams or to things like this, right? We get a collaborative sort of ecosystem. They're all based on these reactive streams types, but then we have specialized implementations where we support different features. So the first thing that we have is called a mono. A mono is a publisher. It's from Reactor. A mono has operators. You can see lots of operators. Look at all those operators to support, filtering and mapping and flat mapping and all these kinds of operations on streams. A mono is a publisher that produces at most one value, so 0 or 1. Okay, think of it like a completable feature, except it supports back pressure. We've also got a flux. A flux is also a reactive stream, but it supports many operators as well, and it supports more than one value. So it could be 0, could be 2, could be 5, could be a billion, could be a trillion. It could be infinite, right? And so you can think of this kind of like a Java 8 stream or a Java collection, except that they support back pressure, okay? Now, I'm going to write and read data to the database, and I want to actually initialize my database. So let's create a Spring Bean here. And this Spring Bean is just going to listen for an event. This event is the application ready event. And when that event gets invoked, I'm going to use that opportunity to write data to the database. And I'm going to do that using the database client, which is a bit like the reactive equivalent of the JDBC template. And I'm going to use my customer repository. Now, I'm using an API here called R2DBC. R2DBC is an abstraction for reactive SQL-based data access. And so you can talk to, I think we have like 10 different implementations. There's Oracle, Microsoft SQL, MySQL, Postgres, H2, SAP HANA. I'm sure I'm missing some, Google Cloud Spanner. I mean, just a whole bunch, right? Like a whole bunch of different SQL compatible databases all have implementations for R2DBC. And that's important because we can't just wrap JDBC. JDBC is a blocking API, so that won't work. And the reason that it assumes that when you ask for data that you can just sit there on the thread and waste a thread. That's not okay, right? So we're going to use this instead. And this database client, we're going to make a call, and we're going to say, let's create a table. And to create that table, by the way, I can use multi-line strings in Java 15. How cool is that, right? So create table customer ID serial primary key. Okay, and what else do we want? We want a name column, varchar 255 not null. Okay, and there we go. There's my SQL. And so I'm just going to use that SQL there to create the database, and I'll say, okay, go ahead and fetch the data and give me the number of rows that were returned rows updated. And then that's going to give me a mono of integer. And then after that's done, then and only then, I want to write some data to the database. So I'm going to create a reactive stream of some names. My name is Josh. Nice to meet you. Who else is on the Spring team? Madura, she's on the Spring team. We've got Violetta, she's on the Spring team. We've got Yushin, she's on the Spring team. We've got Olga, she's on the Spring team. Who else? Dr. Sire, of course, I forgot about him. He's on the Spring team. We've got Stefan on the Spring team. We've got, who else is on the Spencer? There we go. There's 8 names. And I'm going to take each one of these names and I want to turn it into a reactive stream. So I'll say map each name into a new customer. Okay, passing in this. And I'm going to take each one of those customers and write it to the database like so. And I'm going to use flat map. And the reason I'm using flat map is because the return value from save is going to be a reactive stream. So it'll be, otherwise I would have a publisher of customer. What I want is just a publisher of customer. So flat map takes this inner asynchronous reactive stream and turns it into a flattened type of T instead of flux of T, okay? So then once that's done, then I want to get all the data. I'm going to get all the data, and then finally I'm going to subscribe. And subscription is very important, right? Nothing will happen until you subscribe. It's a terminal function, kind of like for each in the Java 8 Streams API, okay? Okay, so there's my basic pipeline, and that's what you should think about it as, right? This is a pipeline. I've defined how things are going to flow together, how the water will flow once the pipes are assembled, but I haven't actually turned on the water until I've called .subscribe. That's the important part there, okay? Okay, there we go. There's my application. There's the data in the database. It worked. That's great, right? So now we've got data in the database. I want to build an HTTP endpoint to serve up that data. So at controller, or at REST controller even. Okay, REST controller. And, I can create a customer REST controller, right? Like this, pretty natural. Private final customer repository, good. And create an endpoint called customers. And the endpoint is going to serve up the customer data. And I'll just return it. I'll say this.customer repository find all, voila. And I want to inject that into the constructor and so on. And that's fine, right? That actually works just fine. Let's go ahead and stop this and then start it that way. That said, you could also do a functional reactive endpoint style, right? So bean router function server response routes. Okay, return. Come on, return route. Good, .build, and you can just chain these things together. And I think this is actually more concise in a lot of respects, right? So you can say, okay, .body, and here I'm going to use the customer repository. I'll inject that collaborating object there. So CR, and I'll say CR.findAll customer.class, okay? Look at that, good stuff. So there's my new HTTP endpoint. And what I'm doing is I'm saying create a server response that has, what is the issue here? Body. Servers, okay. Body. Oh, this is, did I bring in the wrong one? I did, friends. I brought it. No, I didn't. It's right there. Look at that. Maven, reload project. This is supposed to be a handler function. I'm doing something obvious. Let's just do it from the top. So server response dot body is this. CR dot find all is that. Okay. That seems happy. Let's lambdaify it. Good, right? Okay, good. And then static imports, right? So expand, introduce static import, whatever. There you go. So there's my rewritten code. That works as well. So you can either use this controller style, or you can use the functional reactive style, right? I've got the controller working here right now. There's the data. It's working fine. Or if I restarted it, I'd have that as well. So either way works just fine. They're just as long as they don't map to the same endpoint. So customers or customers, but not both, right? Okay, so that's my HTTP endpoint there. I want to create another service here called orders. And this service is going to give me data about orders related to the customers. So I'm going to go here, reactive web. Sorry, I'm not going to use reactive. I'm going to use RSocket. And RSocket is a different protocol. It's not HTTP. It's a binary protocol that was created by engineers at Netflix and Facebook that was designed to meet the limitations that people experience when using things like HTTP and gRPC. It's natively reactive on the wire. It supports many different message exchange patterns, not just request response like HTTP. It's bidirectional, truly bidirectional, so either side can initiate the conversation at any point. Once both sides are connected, it doesn't matter who starts talking first, is my point. One side doesn't need to ask a question before the other can give a response, or vice versa. It's also binary, so it's payload agnostic. It's not HTTP, it's not text at all if you don't want it to be. But you can also communicate any kind of data. It doesn't have to be Google protocol bus. It can be JSON or binary JSON or XML or Avro or message pack or Thrift or whatever, right? The point is lots of different options. By default, we use something called CBOR, C-B-O-R, which is kind of binary Jackson, if you will, a binary API from Jackson. You know, lots of flexibility there. It's got headers, which is nice. WebSockets don't have headers, so if you want to have out-of-band information like tokens, that's very useful. So all sorts of stuff there. We're going to use RSocket. We're going to use Lombok, and we're going to go ahead and start this up. I'm going to create a new project there. And this is just going to be another microservice that will manage data related to orders. So I've got a microservice there called customers. This one will handle orders. And the reason that we care about this, the reason this is a separate module, is because even if I were to delete the customer profile, I still want to have, for revenue recognition purposes and for tax purposes, I need to have information about the orders, right? So that's what I'm doing here. It's a separate microservice. It's going to have a separate lifetime. And this service, I'm going to write a RSocket controller this time. I'm not writing an HTTP controller. So I'm going to say RSocket server port equals 8888. And here, I'm going to create a controller class order controller, right? Whoops, I got too fast, too far, did the wrong thing. Haste makes waste. Do the right thing. You can do better, okay? So what I'm going to do is I'm going to create a map of integers to a collection of something called an order, okay? So we're going to create a little database in memory here. Of course, you could use anything you wanted, but I just feel like it's a pretty trivial example. So I'll create an object here, order, okay? And this order database, I have to initialize it. So I'll say post construct void begin. And here we're going to do the work of actually, filling out that database. And so each order will have an integer for the ID of the order itself and another one for the customer ID. Okay. So same as before, Lombok at all args, no args, etc. And voila, there's my my data stream. Okay. Now, what I want to do is I want to just synthesize randomly some random data. So var I customer ID equals 1, customer ID is less than or equal to, let's say, what did we say, 8? I think we had in there before. So customer ID plus plus. Let's just check. It's always good to check just to make sure. Yeah, there's 8 records. Okay, so we're gonna go through 8, and here what we're gonna do is we're gonna visit each one, and we're gonna create a collection of orders, new array list of order. And then we're going to put all that in the map. So I'm going to say for this will be this dot orders dot put customer ID orders. Okay. And before we put that in there, though, we want to fill out this with some random data. So var order ID equals 1. Order ID is less than or equal to, let's say, math.random times 100. Okay. So it's just going to be some number, and we're just gonna, keep adding stuff to it. So there, orders dot add new order, and it'll be the ID, so order ID, and then the customer ID, right? So we're just creating some simple data. So we have a kind of a distributed one-to-many relationship, but also we have a relationship. And I'm going to create this endpoint and have it available to others in the system. So I'm going to create an endpoint here called orders, and it'll take the customer ID as a parameter. And this is going to just return a publisher, a reactive stream as well. So I'll say order, get orders, and it'll take a destination variable, which is the integer for the customer ID. And given that, we can look up the data from the map and return a reactive stream. So we'll say this dot orders dot get customer ID dot flux dot from iterable. Okay, and there you go. There's my reactive stream of data, and I'm just taking a regular array list and turning it into something that we can use. Now, this is going to start up, and I want to talk to it, so I need to create a client to talk to it. I could, of course, use, I'm going to create a Java client in a second, but I can also use RSC. And so here I'm going to say I want to create an endpoint to TCP localhost 8888. I'm going to make a streaming request, and I think that'll do it, right? That'll actually give me the result I want. Up 0.888 stream. What am I missing here? I want stream. So that's one thing. Let's see what I did wrong. No handler for desktop. Oh, I forgot to specify the route, of course. So route is -r. I'm going to call this orders 2, right? There you go. So when I make that call, it gives me all the data for the customer ID, whose customer ID is 2, and it gives me all the orders for that, okay? So that's working just fine. Now let's create a client to talk to both of these, and this is where we get a lot of benefits from reactive APIs, is we get this easy conformity and easy composition of APIs, okay? And there's a lot of ways we can create services to talk to other things, right? We want to create an edge service here. And so this would be kind of like an API gateway. It'll be an API adapter. And so you can do this a lot of different ways. One thing you can do is use a project called Spring Cloud Gateway. Now, Spring Cloud Gateway makes it trivial to take data and expose it through a proxy of some sort, right? So here, I'm going to create a very simple gateway module, a gateway application. This gateway code uses the reactive APIs behind the scenes, right? So it's a great way to proxy data. And to create a gateway, you just say route locator, gateway, route locator builder, RLB, okay? And return RLB.routes.build. And so each gateway module has a collection of routes, and the routes can do interesting things. They match a predicate. So I can say when somebody comes to this host and port, running on port 9999, server port 9999, when somebody comes to that host and port and goes to /proxy, then we want to send that request to the HTTP localhost 8888 endpoint. Now the problem is that this service downstream, port 8080, the HTTP service, it has no path called proxy. It does have one called customer. So I'm going to use a filter spec here to change the data. I'll say set path to customers. And this is where the real power of gateway comes in, right? Spring Cloud Gateways. I can add retries, I can do request limiting, I can do rate limiting, I can change headers and paths and all that, anything you would do in Nginx or Kong or Apache with mod rewrite, any of that kind of stuff you could do just fine here at super speed and super scale. So that's one option, right? I like that. But that said, one of the things that most people like to do is to compose different data from different sources, right? And this is a very natural use case for reactive API. So let's say I have a CRM client, and this CRM client is going to talk to both my order service and my customer service. So let's copy and paste those DTOs so that we have a way to represent these types at runtime. So customers, here we go. And copy and paste that, good. Paste this, okay. All right, so we have now our DTOs, our client-side representations of these data streams that are gonna be sent over the wire. And I wanna create a client, sorry, wrong one. I wanna create a client here in the gateway that will talk to both services and give me a consistent view of everything. So I'll say get customers, okay, good. And we want a publisher of orders. So get orders for integer customer ID, right? So there we go. There's this as well. So let's see. In order to make this network call, I need a HTTP client, and here we can use the reactive non-blocking HTTP client called web client, okay? And this client, pretty easy to use, pretty easy to get going. We recommend it. Even if you're not talking to a reactive service, you should use our non-blocking reactive web client. We recommend it over REST template all the time, right? It's not, the old one's not going away, but this is just much better, much more reasonable. So I want a non-blocking client. It's pretty trivial to create that. I also want an RSocket requester. Now remember what I said earlier, when you have an RSocket service, you don't really have this concept of a request response. You've got two sides that can talk to each other and do whatever they want. So when the application starts up, they connect and they stay connected. And that's why you specify the host and port once. That socket is multiplexed. It can handle many, many transactions over the life of the application. So private final RSocket requester. Good. Okay, there we go. There's my client, and that's going to be a component. I want to inject the types through the constructor, and now I can use these different clients to talk to these different services. But notice that at the end of the day, all I'm doing is I'm making streams, I'm making calls to services so that I can get a publisher. I get a reactive stream back, and that's where the real power is. I can now have a uniform interface here, right? So body2flux customer.class, and there's that, right? I'm making a call. Good. What about the RSocket one? Well, this.RSocket requester.route orders.customer ID, right? And here, customer ID. And I want to take the data that comes back and turn it into a reactive stream of customer. Now, great, I've got a call to the order service and a call to the customer service. In both cases, things may go wrong, right? So let's suppose that something went wrong. Well, of course, I can use retry. I can retry 10 times. I can retry when a certain condition is met, and I can do, for example, exponential back off, right, or whatever. I can also do error handling. I can say when there's an exception, then just return an empty stream, or I can return an error or whatever. So you have these operators that are built in. You can even do a timeout. Now, timeouts are okay, but there's a much more interesting pattern called hedging. And with hedging, what you're doing is you're launching the same request to different hosts and ports. So you're calling the order service on host 1, host 2, and host 3. And you say, okay, look, one might garbage collect, there might be a pause, service might be down, whatever. Whichever one is fastest, I'll keep that response and I'll throw away the other 2 or 3 or whatever. So very, very easy pattern to understand. But if you had to write that code with manual Java threads, you'd be in a lot of hurt, right? A lot of pain. Instead, use the reactive APIs. It's trivial to express that. So let's suppose that you had 3 pipelines talking to a service, host 1, null, 2, 3, right? So I want to launch all 3 of them at the same time and get the fastest one, and then apply back pressure to the other one. There you go. That's how you do that. Now imagine having to write that multi-threaded, race condition-y kind of code without reactive APIs, and you'd be in a lot of pain. This is a very natural pattern. It's called hedging, and it's done by, Netflix does this, Google talks about it, Uber talks about it. They've all used it at scale. They all use it at scale. So a very useful pattern, better than timeouts too, because it gives you more risk, less risk and more options. Okay, so now I've got these 2 different endpoints. Now I want to create a composite, right? So what I want to do is I want to introduce a new aggregate manifest view, materialized view for everything. And so I'm going to create this new type called customer orders, okay? It's a class, and this type is going to have a list of orders, and a customer, right? So it'll give me a materialized view of both data. And this is something where I'm going to be doing scatter, gather, service orchestration, and composition across the wire, right? This is very natural in a reactive world. So now I've got this type, and in order to make this work, I'll get the customers. I'm going to take each customer. I want to get, for each customer, I want to create a tuple that holds 2 values in memory at once. And I'll say flux.zip, and on the left side of the value, I'll have the customer. On the right side, I'm going to have the orders for that customer, right? So get orders for.get ID. And I want this to be a list. I'm going to collect it as a list in memory. So it's a mono of list. And what I have there, friends, is a tuple. You see that? It's actually a flat map. There you go. What I have there is a tuple. And the tuple has, as the type 1, as the parameter 1, a customer. And on the type 2, it has the list of orders. So new customer orders. Okay, tuple.get T2. There you go. And that's the entire stream, right? That's the entire thing. That's trivial to express. And I have the parameters the wrong way around, do I? There we go. So there's my updated code, trivial to express in a reactive context. Now let's create an endpoint to surface this information. So I'll go up here, and we're going to create one more HTTP endpoint for the day. And it's just going to be a functional reactive endpoint, just like you saw earlier. So router function, server response, HTTP routes, okay? And we'll say return route good.build.get COs, and we're going to provide a customer ID. And when that comes in, we'll produce a response. So let's say r.path variable customer ID var c ID. And we want to turn that into, what is this, route? That routes, okay, that's, okay, so fine. So return server response dot OK.body, and we'll return null for the second just to get that to leave us alone. And all I'm going to do is I'm going to turn that into an integer. So I'll say integer.path variable parse int. Okay, and then we say that we want to call the service. So we're going to use our CRM client. Okay, and we're going to say CRM client dot get orders for integer CID, and I'll send that back. Okay, so I have a reactive stream of customer orders types. Okay, there's my reactive HTTP endpoint. Let's go ahead and start this up. This is going to be on a separate port, 9999, and we'll see that we hopefully will see that that all comes to work. So here we go. This one's for all the marbles. 9999 COs for customer 2. There we go, my friend. So there's the order ID and the customer ID all there, right? So, oh, this is 9999 COs. Wait, yeah, that's right. Okay. Customer. Where's my COs? Come on. Customer orders, customer, list of orders. Good, returning that, returning a publisher of that. Get customer orders. This is what I want. This is what I wanted. So I wanted to get customer orders. Yeah, that'll give me everything. Yeah, I don't need the customer ID over here. Never mind. That's not all that for nothing. So let's try one more time, friends. This is customer orders. So it's going to give me all the customers and then all the orders for the customers. That's the whole point. I'm creating a materialized view. Okay, there we go. There's the customer, number 1. Each customer ID is 1, but then you can see the order ID is 1, 2, 3, etc. So there you go, my friends. I hope you got something out of this. I hope you learned something. We've covered just a little bit of stuff today. We talked about how Spring gives you a uniform way to build more reliable, more robust, more efficient, more scalable services. We took a brief look at some of the nice features in Spring Boot 2.4, including the native image support, and we looked at a reactive application at the very beginning of our time in the context of the Spring GraalVM project. Now we looked at reactive programming, and we looked at basics for data access. We looked at building web services. We looked at microservices, communication patterns. We looked at RSocket. We looked at scatter, gather, orchestration, and composition. And we looked at patterns like hedging. We looked at a bunch of stuff, but we've only just begun, my friends. I really hope you get something out of it. I'm happy to answer questions. Thank you so much for your time. I hope you're safe, healthy, happy, and have a wonderful holiday season. And let's get through this and get to the next year, huh? Thank you.
Thanks, Josh. Thank you so much. That was awesome to see that. So there are a couple of questions in the chat, so I am just going to relay them to you. So the question number 1 is from Ila, asking what should be the approach for calling an API which is not reactive?
What is the what?
What should be the approach for calling an API which is not reactive?
Well, is the client reactive? That's the question. Like you can have, so HTTP is, you can do HTTP with asynchronous IO, but you can't really do full back pressure, right? There's no such thing as true back pressure for an HTTP service because the protocol itself doesn't understand that. So when we have a reactive non-blocking HTTP client, and we have a reactive non-blocking HTTP service, that's very good because they both use asynchronous IO. But if the client wants to slow down the production of the data, if it's already starting to stream the data and the client wants to stop it, all it can do is disconnect. So our WebFlux, Spring WebFlux, the reactive web server, it automatically perceives when something has disconnected and it applies back pressure to the stream that was involved in producing the response. But you can only do that once. It can cancel. That's not the same as requesting 10 records and then just waiting until you need more records later on and then requesting 10 more. You can't do session resumption with HTTP. So you don't need both sides to be reactive if the protocol doesn't understand the back pressure in the first place. RSocket, on the other hand, is natively reactive. It understands back pressure on both sides. So you would be missing an opportunity there. But yeah, I can use my reactive non-blocking HTTP client to talk to anything. I can talk to a PHP website or something. I can talk to anything. So I hope that helps.
All right. So another question is, if I have a software which is based on Akka, can I benefit from reactive system in it? Kind of mixing Akka with reactive?
Oh yeah, totally. So Akka is awesome. Akka is an actor system from TypeSafe now called Lightbend. Akka is a way to do actors. And so the idea behind actors is that each service has its own mailbox. You can send a message to the mailbox, and the actor takes the data from the mailbox and processes the results in a way that they can, and then sends a response back through as a message. This is a super nice way to model software. And if you want to build a service or a system using actors, then it's obvious to most people that you should use actors, right? There are some architectures where you could use it in a lot of different places. Like, for example, message queues. You can use message queues for CQRS. You can use it for event storming, or for event sourcing, or for message transfer, or event notifications. All sorts of patterns can use messaging, but actors, it's just actors. If you know you need actors, it's obvious you need them. And so I don't want you to not use them. But because Akka has something called Akka Streams, Akka Streams is a pipeline technology, kind of like Reactor, which I showed you earlier. So Flux and Mono are from Reactor. And both Akka Streams and Reactor understand the reactive streams types. They both understand publishers. And so I did a video a few years ago, 2 or 3 years ago, showing Spring Web Flux talking to Akka Streams, and then Akka Streams in turn, it can hand off the work of the processing, the actual computation. It can hand that off to an actor system running in the background, right? Running in at scale somewhere. So you can use an Akka cluster running distributed computation, or you can do it in memory in the JVM. It works just fine. I even did that video live in Scala. So go find that. And because they both speak reactive streams, it works. Great idea. Great.
All right. So
programming brings more things together.
All right. There is another question from Christian asking, is it possible to migrate an application from blocking to reactive in multiple steps?
Yes.
As in start adding reactive functionality while still keeping the blocking part working as is without affecting one another?
Yeah, so yes. First of all, Spring Web Flux is not the same as Spring MVC, but because we know that a lot of people are going to be doing exactly that, we made it possible to move applications slowly, one step at a time. So for example, if you have a controller method that returns a collection of customer instead of like a publisher, that's fine. It'll work. We make it work, right? Things like that. So common stuff, you can get a lot of mileage just by copying and pasting. The second thing is, if you're using like Tomcat or Jetty or things like that, we have a certain configuration where you can run kind of, mostly reactive code on top of a servlet engine. So we're not using a servlet engine in the code I just showed you. There's no servlet API, but we're using Netty, N-E-T-T-Y, not J-E-T-T-Y. And that's a non-blocking, fully asynchronous library that's great for reactive programming. That said, if you want to use a servlet engine, we can make that work. We can adapt the Tomcat engine and Jetty and so on to work in a way that kind of looks right. So you can actually run on top of Tomcat and have reactive controllers. That's the other option. So as a piecemeal. The other thing to keep in mind is you can have reactive code and non-reactive code in the same code base, as long as you're being smart about moving the non-reactive code to its own separate thread pool or its own separate scheduler. In Reactor, a scheduler is the thing that moves work from one thread to another. And there's one that's there by default. You have one thread per core. So if you have 4 cores, you have 4 threads. Each thread is an event loop, kind of like Node.js, right? And so as a result, if you block that thread, that's not just one user that you're blocking 25% of your users, right? 1 out of 4. So it's very important that you use the operators in Reactor, publish on and subscribe on, to tell the pipeline to run on the separate thread pool. That way you don't ever do any blocking work on the main non-blocking reactive thread pool. The other thing is we have a Java agent called Blockhound. Blockhound, you add it to the class path, you just install it, you say blockhound.install and add to the class path, and whenever you do anything on the main thread pool that's non-blocking, but you're doing work that is blocking, it'll throw an exception. So it'll help you figure out where you need to be careful about moving that work to a separate thread pool. Keep in mind, you won't get the same scalability benefits if you have non-blocking code in the hot path of your pipeline, but at least you now have a uniform API, you have the operators to make more reliable code, and so you can make your code better and better and better progressively without having to do the whole thing at once. I hope that helps.
All right. Thank you so much. Next one is my favorite. Isn't Spring Reactive a catch-up to what Vertex has been providing?
Vertex?
Yep.
Is Spring Reactive a catch-up to Vertex?
Yeah.
No, so Vertex is Vertex is kind of like Reactor, right? Vertex, by the way, we came out first. I don't know if people know that. Project Reactor came out from VMware in 2010 or 11, right? And did you know, my friend, Vertex actually started on the open source Spring team? I don't know if people know that. So go back in time, go back to 2011, you'll see that that was created, it's called node.x, and then the name got changed to Vertex. Then we donated it to the Eclipse Foundation, right? And then, so it's there now, but it was part of VMware. It started there with us. So no, it's not catching up. We created Reactor. Vertex was a separate thing. And Vertex does a little bit more than Reactor, but not nearly as much as Spring, right? Spring is a much bigger ecosystem than Vertex. So Reactor plus Spring gives you huge, huge opportunities. That said, if you are using Vertex and you like Vertex, it's fine, right? Now we can talk to each other. Now you can have Spring and Vertex in the same code base because they can both use Publisher. So that's another benefit of this this collaborative effort from 5 years ago, 6 years ago.
All right. So we are going to take the last question and then we'll jump onto the spatial chat. So Ila wants to know the use cases for reactive system versus actor model.
Actors have a very specific use case, which is I want to have my state and my structured concurrency described in a way that looks like an actor system. So it's sort of like if you look at the original use cases for for Erlang OTP, the use cases were that they didn't trust people to handle state transitions, state changes in a context multi-threaded environment. So they said, okay, we're going to make it as simple as possible to handle concurrency, in that the only way to handle concurrency is through implicit message passing or explicit message passing, right? So there's no shared private final concurrent volatile variables or anything like that. The result of that was that if you're willing to express your algorithm in this new way, in this structured concurrent way, then the runtime can provide you benefits. And one of the benefits it provides you is a hypervisor system. So the hypervisor, it looks at all the actors that are out there. If one of them fails, it restarts the actor. The result of this is that you have to write your code in such a way that it's idempotent, right? So actor systems, you don't have to do reactive with an actor system. Did you know? That's the first thing. They're not the same thing. They don't have to be the same thing. You can do blocking actors. But because it requires you to be idempotent, it's a very structured way to do it. You have to change the way you think about things. Reactive, on the other hand, it works with everything. Like, for example, I can use reactive Kafka. Instead of having a hypervisor system, I can have a broker, and the broker can redeliver the message until it gets done. So that's kind of like the hypervisor. I get the same retriability, and that requires me to also rethink the code. So actors are very specific. You can get the same effect as actors, and you still have a bunch of other options as well. But because they're both reactive, because both Akka streams in particular, and because of Spring both speak the reactive APIs, they can also talk to each other, right? So Spring is a bigger opportunity, bigger tent. Akka is awesome for the use cases for which it's perfect purpose built.